So this video is about how to find compound interest. So before I actually go into compound interest, I'm just going to quickly remind you of how to use multipliers to increase by a percentage and decrease by a percentage. So first of all, if you're increasing £35 by 12%, the first thing, there are different ways to do this. You can find 12% and add it on. But like I said, today I really want to try and use the multiplier method to do that, because it's actually quite helpful then for working out compound interest problems later. So if you're increasing £35 by 12%, first of all, increase means it's going to go up. So initially it always starts off as 100%. If I'm increasing it by 12%, so adding 12%, it's now going to make 112%. And to get your multiplier, you just divide that new percentage now by 100. So if I divide that by 100, I'd get 1.12. So to increase £35 by 12%, I just need to do 35 times 1.12. So although there's different ways to do finding 12% or increasing 35 by 12%, I still think this is actually, if you're allowed a calculator, I still think this is the quickest way to do it. So if I times it by 1.12, I get an answer of 39.2, and this was money, so I'd have to make that £39.20. So the next one, very similar. I just thought I'd show you one with a decimal in it. That might be a little bit trickier. So we're going to say again, starting on 100%, it's another increase, but this time by 2.5%. So this time I'd be adding on 2.5%. So that's going to make it now 102.5%. So to get your multiplier, you still need to divide that by 100. So if I divide this by 100, if you don't know how to do it, you could use a calculator, but if not, just move your point back twice. So it would be 1.025. So I would need to do 27 times 1.025. So 27 times 1.025. And you get an answer of 675. So I've got to do it to 2 decimal places because it's money. So it would be 27.67. However, the 5 makes the 7 go up to an 8 because it's 5 or more. So it would be 27.68. So a decrease is exactly the same. I'm just going to swap my pen because that one's not particularly great. Let's try this one. So a decrease is exactly the same method, but this time, rather than adding on that percentage, I'm going to be taking it off. So it's still 100% to begin with, but this time I'm going to decrease it by 7%. So this time I'm going to take off 7%, which leaves me then with 93%. And again, I still want to divide that by 100, so it would be 0.93. So I still need to times it, so it would be 124 times 0.93. So let's do it now. So 124 times 0.93. So I get an answer of 115.32. And the final one, so again, another decrease, 3.5% this time. So again, start on 100, but this time I'm going to take off 3.5%. So that's going to leave me with 96.5%. So again, I still need to divide that by 100, which would be 0.965. So it's going to be 98 times 0.965. So that makes it 94.57. Right, the next one then is an introduction to the compound interest, and then I will go over some examples that will probably help you a little bit more in a minute. So with compound interest, it means that if they're getting 3%, annual means every year, so every year they're going to get 3%. But the difference between compound interest and simple interest is that with compound interest, they would work out 3% and add that on. And then the next year, they would work out 3% of that new amount and then add that on. And then the next year, they'd work out 3% of that new amount and add it on, and so on. Rather than just working out 3% of the initial amount and timesing it by 5. So it keeps changing. The amount in their bank every year keeps changing because they keep adding on 3% of the interest. So it's just slightly different to the simple interest idea. So if you think about it for 1 year, we would want to increase it by 3%. So you would do 300. If I'm increasing it by 3%, then it would go from 100% to 103%, which is 1.03. So for 1 year, I would times that by 1.03. So if I put there 1 year. If I'm doing this for 5 years, you've then got to think, right, well, for the second year, I would get whatever that answer is, which I don't know at the moment, but let's just keep it like that. So say that's my answer for the first year. I would then, for the second year, want to increase it again by another 3%. So I'd have to times this by another 1.03. And you can see here, like I've got two 1.03s that have been times together. So another way to write that would be 300 times 1.03 to the power of 2, or squared. So if I was doing it for 3 years, the trick is the power here is always the number of years. So if I'm now doing it for 3 years, I would do 300 times 1.03 to the power of 3. And so going back to the question, which is 5 years, I would do 300 times 1.03 to the power of 5. So your multiplier is just looking at that interest, adding it onto 100 and dividing it by 100. Obviously, if it's a decrease question, you'd have to take it off. And then the power is just the number of years or the number of days, depending on what the question is asking you. But that's always what that power there is going to be. So if we have a look at these questions here now. So question 1, I don't know how well you can see that, so let's just zoom in a little bit. There we go. So a bank starts with a balance of £4,000. So that's going to be important. It's compound interest, 5% per year, so that's going to be important. We've got to work out the balance of the account after 1 year and after 2 years. So the first thing is that it's 5% interest, so it's going to go from 100% to 105%, which is 1.05. So that's going to be my multiplier. And the starting amount is £4,000, isn't it? So I'm going to start with £4,000, and then I'm going to times that by 1.05. And actually the first question is only asking for 1 year, so that would work out the answer for the first year. So let's just type that in now, see what we get. So 4,000 times 1.05. So after 1 year, they would get £4,200. Right, after 2 years then, all I need to do is just make this to the power of 2. So this one would be 4,000 times 1.05 to the power of 2, because this time it's 2 years. So then you get 4,410. Right, question 2. Very similar really, you've just got to work out what multiplier is going to go in here. So again, it's compound interest, so it's going to get added on. It's a rate of 2%. So if it's 2%, it would go from 100% to 102%. Divide that by 100. So my multiplier would be 1.02. So I will just add that on so you can see what I've done. So I've just divided it then by 100, and then that's your multiplier. That's all you need to do for that question. It's just filling in what that multiplier would be. It's not actually working it out. Question 3. So Bryn takes out a loan of £800. The debt increases by 28% every year. How much money will he owe after 14 years? So first thing is increasing by 28%. So it's going to go from 100% to 128%. Divide that by 100, 1.28. So that's going to be our multiplier. So I'm going to do 800 times 1.28, and it's for 14 years, so it's going to be to the power of 14. So I'm guessing that he's going to be owing quite a bit of money. So 1.28 to the power of 14 years. So it's going to be 25,353 to the nearest penny, isn't it? So I'm going to have to do it in like pence here. So it's going to be 0.1. So poor Bryn has got a lot of money to owe. Question 4, last one. So this time it's 3.5%. That will be important. £4,000 going into it. Now the only thing with this question is that it says how much interest. It's not asking for her total amount in the bank after 6 years. It's just the interest that they're interested in. So I would still work it out the normal way, but at the end of it you're just going to have to take off the 4,000 because we're only looking at actually how much interest she would have earned. So it's 3.5%, so it would start on 100. I'd have to add on 3.5, so that would be 103.5. Divide that by 100, so move the point back. So 1.035, there's our multiplier. So it's going to be 4,000 times 1.035 to the power of 6, because it's for 6 years, so let's work out that. So that is 4,917.02 to 2 decimal places. Remember, money's always got to be 2 decimal places. However, it's asking for the interest, not the total amount. So that would be the total amount in her bank, but we want to work out the interest. So we just need to take off the initial 4,000 that she put in. So the interest is just going to be the £917.02.